Hello everyone. Today we are going to discuss about an elementary idea in mathematics. It is called coordinate bashing and trigonometry bashing. This idea is used to solve many problems in an elegant way, but sometimes that can take you a detour of the easier solution. So you have to be clever in its application. I recommend you to first try and attempt a trigonometry solution in exams. You find synthetic solution in a harder way, but the number of steps required to solve with it is too less. The opposite happens for trigonometry or coordinate geometry, but sometimes they are both equal. Identifying the existence of synthetic solution might take some time, but doing it in homework consolidates that potential and skill in your mind. So let's get started with trigonometry bashing in this problem. Here is the question. ABC is a triangle with angle C being 90 degrees. The triangle is right angled at C as shown. So the hypotenuse is AB. There is a point D on the segment BC and BD equal AC root 3. Let's take AC as B and BD will be B root 3. Point E is chosen on the segment AC. So let's consider E over here. If you take the length of CD to be L, then AE is L root 3. Alright, the question is to find the angle between AD and BE. The acute angle, so that means this one. Acute is an angle less than 90 degrees. Now, we are going to assume the point C as origin and assign coordinates to the points A, E, D and B, using which we will find the slope of lines AD and BE and find the angle between them. Now try to attempt this question once by yourself and add the ideas in your comments before looking into our solution. Now we will get started with our solution. The coordinate of point D will thus be L, 0. CB is considered as x-axis, CA is considered as y-axis. And the coordinate of B would be L plus B root 3, 0. Alright, now coordinate of point E. So the total length AC is considered as B. So let's write all our assumptions. AC is considered as B, CD is considered as L. So therefore, the length CE will be B minus L root 3. Coordinate wise point E will be 0, B minus L root 3. And coordinate wise point A will be 0, B. So let me also annotate the x and y axis. This is x and this is y. Finding slopes, how is it helpful in finding the angle between the lines? Slope is actually the tan of angle made by the line with the x-axis. So you have to subtract those two angles and find the tan value using the tan values of individual angles. First, we will find the individual tan values, which is the slope. Let M1 denote the slope of AD. And how to compute the slope? It is nothing but y2 minus y1 by x2 minus x1. The difference in y coordinate by difference in x coordinate gives us the slope. This is because tan theta is opposite by adjacent and you take 2 points on a line with x2, y2 and x1, y1. y2 minus y1 will be the opposite and x2 minus x1 will be the adjacent length for the angle subtended by it on the x-axis. This comes through the definition of tan theta, nothing logical here. Now the difference between the y coordinates is b minus 0. And the corresponding x coordinate difference should be considered, which is 0 minus L, and that gives us minus b upon L. So similarly, we will find the slope of line BE. Slope of BE. That will be b minus L root 3 minus 0 upon 0 minus L minus B root 3. So let's simplify this now. M2 will be L root 3 minus B upon L plus b root 3. Okay, a way of writing slope is tangent of the angle made by it with the x-axis. So this is tan theta 1 and this is tan theta 2. Now we are interested in the angle made by those two lines, which is theta 1 minus theta 2. It can also be considered tan of theta 2 minus theta 1. It depends on which is acute and which is obtuse. Here we are interested in acute angle, but we will chase whatever we get, and if it is going to be obtuse, we will subtract it from 180. If it's acute, then that's our required answer. Simple. Tan of the difference theta 2 minus theta 1 has an expansion tan theta 2 minus tan theta 1 upon 1 plus tan theta 2 tan theta 1. So we are going to substitute the values of slope that we found, m2 minus m1 by 1 plus m1 m2. Let us substitute the values. You get L root 3 minus b upon L plus b root 3 minus b by L upon 1 plus L root 3 minus b by L plus b root 3 times minus b by L. So here we are going to take the LCM in numerator and denominator and cancel the common denominator. So you get L squared root 3 minus LB plus LB plus B squared root 3 whole divided by L square plus LB root 3 minus LB root 3 plus B square. And we are going to arrive at something quite simple. LB and minus LB goes off, LB root 3 and minus LB root 3 goes off. So you get L square plus B square times root 3, the whole divided by L square plus B square, which is just root 3. So this is the computation of tan theta 2 minus theta 1. That is either one of the obtuse or acute angle between the two lines. So we thus conclude theta 2 minus theta 1 is 60 degrees. This is just by the trigonometric ratios of certain well-known angles. Tan 60 is root 3. I am using that to conclude the difference is 60. So pictorially, let me give you how those lines subtend theta 2 minus theta 1 between them. So this is how they are oriented. This angle is theta 2. The angle made by it measured from the positive x-axis. And theta 1 is the angle made by the other line measured from the positive x-axis. So you could see the difference between theta 2 and theta 1 must be the angle formed between them, which is just proved by the sum of two interior opposite angles equal the exterior angle of a triangle. So second question is, how do we know whether to apply trigonometry or synthetic ideas to solve this? Synthetic ideas just mean angle chase and cyclic quadrilaterals and so on. The thing is, if you find lot of trigonometric ratios already embedded into the structure, or if you have lot of lengths and angles already provided, try incorporating trigonometry. If not, try thinking with synthetic. But if you start with some idea and you are stuck at some point, then I recommend you to switch to another solution if you feel stranded and you seem to go nowhere out of those ideas. Let's meet in another video to discuss more ideas like this. Thank you everyone.